everyone, this is the third grade Enhanced Math Week 11 Introduction to Fraction Solution video. The numerator and denominator of a fraction are the top and bottom numbers of a fraction. In this example, 5 being the numerator, which is on top, and 8 being the denominator, which is at the bottom. So an easy way to remember this would be to see that denim, which is basically, if you don't know, part of a pant, which is the material used to make pants. And since pants go below you, that's an easy way to remember that denominator goes below the line, while numerator just goes above the line. Below are some examples. So 1/8, we see here that a pizza, 8 being the whole and 1 being the part. So let me write down 8 being the whole. And as you can see, the pizza is cut into 8 slices, and then there's 1 slice taken out of it. So that would be the part. And then on the right-hand side, we can see that just the 1 is the entire pizza, 1/2 being 2 parts of the pizza and 1 being taken out, 1/4, again, 4 parts and 1 taken out, and 3/4, 4 parts but 3 taken out. Note that fractions with different numerators and denominators could represent the same value. For instance, 1/2 equals to 2/4 equals to 4/8. As we see here at the bottom, 1/2 is at the same line as 2/4, and 2/4 is at the same line as 4/8. So they fill in the same number of area, but it's just different portions. Problem 1. Find the right fraction of shaded areas. Let's start with the first one. We see here that there are 2 squares and 2 squares that have been cut into 2 triangles. So let's just cut up the rest of the squares. And then we see here that we have 8 triangles and 2 of them are shaded. So that would just be 1/4. So 1/4 of the area is shaded. Moving on, we see here in the circle that the outer ring, so let me highlight the outer ring. The outer ring, we see here that just 1/2 of it is shaded because there are 2 parts that are shaded and 2 parts that are not shaded. And then the ring is just cut into 4 different of the same pieces, and 2 pieces are shaded, 2 pieces are not shaded. And then we see here in the middle ring in red, the middle ring, again, we see here that 2 pieces are shaded and 2 pieces are not shaded, and then they are the same exact size. So from this, we can just conclude that 1/2 of the entire area is shaded. The next one, there are 5 triangles, so 5 being the denominator. And then since 3 triangles are shaded, so that would just be 3/5. And then finally, over here, we see here that the part shaded in yellow, so I'm shaded in yellow, when carried down over here to the place marked in red, this creates 2 rectangles. So since there are 5 rectangles in total, this would just be 2/5. And these are answers to problem 1. Problem 2, what fraction of the square is shaded? We see here that at the top first, the area shaded in red, so let me shade it in red, is equivalent to the area dotted in red. So let me dot this area in red. So these two are the exact same copies of each other, just in different positions. The next one I'm going to shade in green. This part in green, shaded in green, is equivalent to this part dotted in green. So these two are the exact same. And then finally, the last part, this part shaded in yellow is exactly the same as this part down shaded in yellow, dotted in yellow. So as you can see, 1/2 of it is just the flip side of the other one. So in reality, this is just a big 1/2. 1/2 of the square is shaded. Problem 3, what fraction of the square is shaded? Looking here, we see here that there are tiny triangles, so we need to fill in these and see how many triangles there are, and then we can solve it from there. Once filled out, we can see here that we can just count up the triangles. So I'm going to count with you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And then there are 25 small triangles. And then out of these 25 triangles, we see here that each hexagon is made out of 6 triangles. So 6 plus another 6, since there are 2 hexagons, equals to 12, plus the remaining small triangle, plus equals to 13. So the answer is 13/25. Problem 4. Amelie and Eliza have 2 equal-sized glasses full of water. Ellie drank 4/8 of the glass, and Eliza drank 7/8 of the glass. Which of the following number lines represents the amount of the water each of them drank? As we see here in this number line from 0 to 1, it is marked up in 8 different sections, so each one representing 1/8. So the first one would just be 1/8, the next one would be 2/8, the next one 3/8, the middle we would be 4/8, then 5/8, then 6/8, then 7/8, and then finally 8/8, which is just 1 at that point. We need to find the part where Ellie drinks 4/8, so that would be in the green. So far, we already narrowed it down to A and B, since C and D don't have Ellie's point on 4/8. So then we can move on to either A or B. So either A or B. And then we have to see which blue line, which represents Eliza, is on the 7/8 of the glass. And of course, that's just B. So in reality, B is our correct answer. Problem 5. Derek cut a whole pizza into 8 equal pieces and ate 3 pieces. Then his brother Eric ate 2 pieces as well. What fraction of the whole pizza was left? So Derek cut a whole pizza into 8 equal slices. So let's just say slices. So we can mark this up. So there you go. That would be 8 slices of the pizza. And he ate 3 slices. So let's shade in 3 slices so that he ate it. 8. And then his brother came and ate 2 slices. So let's shade that in again. So we're left with 3 slices. So what fraction of the whole pizza was left? Well, 3 slices out of the 8 total slices that we began with. So it's 3/8. Problem 6. Rank the following fractions from the least to greatest. Before we start this, we know that if we keep the same numerator and the larger the denominator gets, actually that creates a smaller fraction because you're cutting the pizza. Let's imagine that there's a pizza. You're cutting it into more pieces. So you only have this large of a pizza, and the more you cut it, the more smaller slices you're going to get. Looking from that, we know that 1/9 has to be the least. So 1/9 is the least since you cut it into 9 pieces. So each piece is going to be smaller. The next one would be 1/6 because 1/9 would just be smaller than 1/6. 1/6 still cut into 6 slices. And then that would still be smaller than 1/4 because you cut it into 4 slices. So that's larger than 1/6 of a slice. And then what's even larger than 1/4 of a slice is 1/3 of a slice. And what's even larger than 1/3 of a slice is 2/3 of a slice. So this would be your lineup from least to greatest. Problem 7. A square of paper is folded in half to make a triangle, then in half to make a smaller triangle, then in half again to make an even smaller triangle. What fraction of the area of the original square equals to the final resulting triangle? We start off with 1/1 because this is just one whole square. And then following that, we get 1/2 of the original figure. So let's just write 1 for the start. And then for the next one, we get 1/4 of the original figure because it's 1/2 of 1/2. And then finally, what's 1/2 of 1/4? That's just 1/8, which is the final resulting figure. That's 1/8 of the original figure, so therefore the answer is 1/8. The fraction of the original area of the original square equals to the final resulting triangle. Problem 8. Takis was reading a book. On day 1, he read 1/7 of the whole book. On day 2 and day 3, he read 2/7 of the book each day. What fraction of the book did he need to read on day 4 in order to finish the book? So we know that on day 1, he read 1/7 of the book. And then on day 2 and 3, he read 2/7 of the book for each of these 2 days. So that means that 2/7 plus 2/7 equals to 4/7 of this book read in these 2 days. Because as we see here, when we add 2/7 plus 2/7, we only need to add the numerators, not the denominators. Therefore, day 2 and 3, he read 4/7 of the book. Therefore, we add up these two. So 1/7 plus 4/7 equals to 5/7. And then for day 4, let's write day 4. Day 4, that's basically just 7/7, which is just 1 because that's the whole entire book, subtracted from the number of pages that with the portion of the book that he read on the previous 3 days. So 5/7 equals to 2/7 remaining. Therefore, on day 4, he has 2/7 of the book remaining in order to complete the book. Problem 9. There were 24 students on the playground. 1/4 of them were playing handballs. 1/3 of them were playing basketball. Half of the remaining students were doing swinging. How many students were doing swinging? First off, 1/4 of them were playing handballs. 1/4 of them, and then 1/4 of 24. Well, we know that since, let me just put it this way. 24 students in total, and then you divide it by 4 since 1/4. This would just give you 6/1. And then that would just give you 6 students. So 6 students that are playing handballs. And then 1/3 of them were playing basketball. So again, we have 24 students. 1/3 of them were playing basketball. So we just divide it by 3. And this gives you 8 students that are playing basketball. And then finally, half of the remaining students were doing swinging. So half of the remaining students, we need to calculate 6 plus 8 because these are the students that are playing the other activities. So 6 plus 8, that's just 14 students, 14 kids, let's say. And then since there are 24 students at the beginning, so we just do 24 minus 14 equals to 10. And then of course, half of 10 would just equal to 5. So how many students were doing swinging? 5 students. Problem 10. The bar graph shows the grades in a mathematics class for the last grading period. If A, B, C, and D are satisfactory grades, then what fraction of the grades shown in the graph are satisfactory? So we see here that F is the only grade that is not satisfactory, so we need to see how many people got F. And as we see here, if we line it up to the numbers on the left, we notice that F has 5 students. Therefore, the not satisfactory, so let's write not satisfactory, equals to 5 students. And then now we need to calculate the total number of students. We have 2 5 students, both A and F, so 5 plus 5 equals to 10. 5 plus 5. And then we have B, who has 4 students that got a B, so that equals to 14. And then we have 2 grades, C and D, which both have 3s. So plus 3 and plus 3, this gives us 20 students. So in total, if 5 got not satisfactory, that means that 20 minus 5 equals to 15 students got satisfactory out of the 20 students in total, and we can just simplify this to 3/4. So 3/4 students got satisfactory.